Welcome to lecture 2 of bivariate Gaussian random variables and sum of two independent random variables. In the previous lecture we had worked out some questions on bivariate Gaussian random variables. So we'll continue with the exercise questions on sum of two independent random variables. Two independent random variables x1, x2 are uniformly distributed between 0 and 1. Z is equal to sum of the two independent random variable x1 and x2. Z is equal to x1 plus x2. What is the probability density function of Z? So here clearly x1 and x2 are two independent random variables and both are uniformly distributed between 0 and 1. Since x1 is uniformly distributed between 0 and 1, the probability density function of x1, fx1 of x is equal to, here the interval is ab, which is 0, 1. So probability density function of x1, fx1 of x is 1 by b minus e, 1 by 1 minus 0 or equal to 1. It is equal to 1 for all x between 0 and 1 and 0 otherwise. Similarly, x2 is uniformly distributed between 0 and 1. So probability density function of x2, fx2 of x is equal to 1 by b minus a, 1 by 1 minus 0 or equal to 1 for all x between 0 and 1, 0 otherwise. So we have the probability density function of x1, probability density function of x2. We are asked to find the probability density function of the sum x1 plus x2. That means probability density function of Z, where x1 and x2 are two independent random variables, and the probability density function of the sum of two independent random variables is nothing but the convolution of the probability density function of x1 and probability density function of x2. So the probability density function of Z is given by equal to integral from minus infinity to plus infinity fx1 of x into fx2 of z minus x dx. Here fx1 of x is equal to 1 for x between 0 and 1. For all other x values, fx1 of x is 0. So this first factor will be equal to 1 for x between 0 and 1, 0 otherwise. So in this integral you need to consider integral from 0 to 1 so that fx1 of x can be replaced by 1. And for remaining x values, this fx1 of x is 0 means the whole integral will be 0. So this integral changes to integral 0 to 1. fx1 of x is 1. So 1 into fx2 of z minus x dx. Integral 0 to 1 fx2 of z minus x dx. And see that probability density function fx2 of x. fx2 of x is 1 for all x between 0 and 1. Now it is not fx2 of x but fx2 of z minus x. So by that definition of fx2 of x, this fx2 of z minus x will be equal to 1 for all z minus x values between 0 and 1. For all z minus x values greater than or equal to 0, less than or equal to x. Now it is not fx2 of x but fx2 of z minus x. So instead of x it is z minus x. fx2 of x is 1 for all x between 0 and 1. So this fx2 of z minus x will be 1 for all z minus x values between 0 and 1. That means z minus x is greater than or equal to 0 means x will be less than or equal to z. And z minus x is less than or equal to 1 means this x will be greater than or equal to z minus 1. So z minus x is greater than or equal to 0, less than or equal to 1 implies that x value should be greater than or equal to z minus 1, less than or equal to z. Or z minus x is greater than or equal to 0 means z must be greater than or equal to x. Z minus x is less than or equal to 1 means z must be less than or equal to x plus 1. So z minus x should be greater than or equal to 0, less than or equal to 1 implies x must be greater than or equal to z minus 1, less than or equal to z, or z must be greater than or equal to x, less than or equal to x plus 1. Now since z is the sum of x1 and x2, range of x1 is 0 to 1, x2 is also 0 to 1. If we take the sum of x1 plus x2, sum of x1 and x2, then the sum z will lie between 0 and 2. Lower bound will be 0 because both x1 and x2 the lower bound is 0. Upper bound maximum value of x1 is 1. Maximum value of x2 is 1. So when you add x1 and x2, maximum value of x1 plus x2 will be 1 plus 1, 2. So z lies between 0 and 2. Now as the first case, we need to calculate this fz of z, which is integral 0 to 1 fx2 of z minus x dx. Now we need to find this fx2 of z minus x and then complete the integration part. We have this fx2 of z minus x as 1 provided x is greater than or equal to z minus 1, less than or equal to z, and that z is between 0 and 2. So we'll split this into two sub-intervals. It is integral 0 to 1 fx2 of z minus x, probability density function of x2, and the interval where x2 lies is 0 to 1, interval of length 1. So what you do is split this interval for z, which is from 0 to 2, into sub-intervals of length 1. So starts from 0, sub-interval of length 1 means it should be 0 to 1. Then from 1 to 2, again sub-interval of length 1. So first take z as greater than or equal to 0 up to 1, less than or equal to 1. So it will be sub-interval for z of length 1. When z, so as the first case, when z is greater than or equal to 0, less than or equal to 1, this fz of z will be equal to. Now z is greater than or equal to 0, less than or equal to 1. So when z lies between 0 and 1, this z minus 1 will lie between minus 1 and 0. When z is 0, z minus 1 will be minus 1. When z is 1, z minus 1 will be 0. So this z minus 1, the lower bound of x, that z minus 1 will lie between 0 and 1. Sorry, minus 1 and 0. Minus 1 and 0. So you start with, because x cannot be negative values, so you start with the lower limit is 0 itself. X will be from 0 to, since z lies between, z is any value between 0 and 1, that x is also between 0 and 1, so upper limit you can take it as this z itself. We have this integrand fx2 of z minus 1, z minus x is 1 provided x should be greater than or equal to z minus 1 and less than or equal to z. So this fx2 of z minus 1 I can write it as 1. Then I have to see what should be the lower limit and what should be the limit of integration. Anyhow x is greater than or equal to 0, so lower limit should be 0 itself. I can't take any value less than 0. Upper limit, since I have taken z between 0 and 1 and x should be, if fx2 of z minus x is to be taken as 1, then that x should be less than or equal to z, and that z now it is in between 0 and 1. So we know x is between 0 and 1, so this upper bound is between 0 and 1, any value between 0 and 1. So for this integral we can take integral from 0 to that z value, which is any value between 0 and 1. Since x should be less than or equal to z, now upper for this integrand to be 1, x should be less than or equal to z, and that z value is taken as between 0 and 1. So upper limit can be taken as this z. Lower limit z minus 1, but when z is between 0 and 1, this will be between minus 1 and 0. So ignore all the values, start with 0, this lower limit is 0 itself because x are not negative. So ignore that negative values, you start with the lower limit 0 itself. So integral 0 to z, this is 1 dx, and integral dx is x, difference at the upper limit z and lower limit 0. So it will be z minus 0 or equal to z. Second case, z is actually between 0 to 2. We have already considered z as between 0 and 1. Then take that in subinterval again of length 1, because x2 lie in the interval of length 1. So 0 to 1 is already considered for z. So start from 1, take a subinterval of length 1 to 2. So z is greater than, second case, when z is greater than or equal to 1, less than or equal to 2. Now this fz of z will be equal to, now in the integrand fx2 of z minus x, it can be taken as 1 provided x lies between z minus 1 and z. Now what should be the lower limit? When z is greater than or equal to 1 and less than or equal to 2, this z is greater than or equal to 1 means z minus 1 will be greater than or equal to 0. Less than or equal to 2 means z minus 1 will be less than or equal to 1. When z is 2, z minus 1 will be 1. When z is less than 2, z minus 1 will be less than 1. So for all z values between 1 and 2, this z minus 1 will be between 0 and 1, and x should be greater than or equal to that. 0 up to 1, x should be greater than or equal to this value z minus 1, which is between 0 and 1. So here in the integrand, integration is with respect to x, and fx2, and this x, for this fx2, this x is between 0 to 1. So lower limit can be taken as z minus 1 itself, upper limit. Now z is between 1 and 2. So x should be less than or equal to that z, which is between 1 to 2. But x is maximum value is for x is 1. So this z is 1 to 2. In that you take only 1, ignore the remaining because x cannot be greater than 1. So x is less than or equal to 1. Ignore that values of z after 1. So upper limit is 1 itself. So this integral will be fz of z is equal to integral from z minus 1 to 1 into 1 dx, or integral dx is x, difference at the upper limit 1, lower limit z minus 1, so it will be 1 minus z minus 1 or equal to 2 minus z. Verify when z is 1, fz of z will be, z means it is 1 itself, or else if we take this, when z is 1, fz of z will be 2 minus 1 or 1. Whether you use this fz of z as z or fz of z as 2 minus z for z equal to 1, both will give the same answer. So that's why we have included 1 on both subintervals. Now when z is less than 0, when z is less than 0 or greater than 2, z is less than 0 means x should be less than or equal to z, and this z value is less than 0 means obviously x should be less than 0. Z is greater than 2, then z minus 1 will be greater than 1, so x will be obviously greater than 1. So when z is less than 0 or z is greater than 2, x will be less than 0 or x will be greater than 1. But since both x1 and x2 are uniformly distributed between 0 and 1, for x between 0 and 1, fx1 of x or fx2 of x will be equal to 1 and 0 for all remaining x values. So here x less than 0 won't come between 0 and 1, or x greater than 1, that also will not be in between 0 and 1. So in that such a case, for these x values or for these z values, both fx1 and fx2 are zeros. Fx1 of x is 0 means the whole integral will be 0, or the probability density function fz of z is 0. So for these z values greater than 0 or less than 0 or greater than 2, which means x is less than 0 or x is greater than 1, fx1 of x and fx2 of x both are zeros, and hence fz of z will be equal to 0. So we have the probability density function of z, fz of z as equal to z for all z values greater than or equal to 0, less than or equal to 1. Fz of z as 2 minus z for all z values between 1 and 2, and fz of z as 0 for all the remaining z values. We have the probability density function of the sum z, which is the sum of two independent random variables. For that sum of two independent random variables which is uniformly distributed between 0 and 1, we have the probability density function fz of z. Next question. If x is a random variable uniformly distributed between 0 and 3, so x is a random variable uniformly distributed between 0 and 3. So the probability density function of x will be fx of x is equal to 1 by 3 minus 0 means 1 by 3 for all x greater than or equal to 0, less than or equal to 3, 0 otherwise. Y is a random variable independent of x. So x and y are two independent random variables, and y is uniformly distributed between -2 and +2. So probability density function of y will be 1 by 2 minus of minus 2, 2 plus 2, 1 by 4 for all x, for all y values between minus 2 and plus 2. So we have probability density function of x, probability density function of y. Now w is the sum of two independent random variables x and y. What is the probability density function of that sum? Just like the previous question. And this is the question from the model question paper of 2020. So we need to find the probability density function of the sum, probability density function of w, where w is the sum of two independent random variables. Probability density function of w will be convolution of the probability density function of x and probability density function of y. So the probability density function of w, fw of w, will be equal to integral from minus infinity to plus infinity fx of w minus y into fy of y dy. There are two formula for integral formula for the probability density function of the sum of two independent random variables. You can take any one of these two. Now in the previous question we had used that probability density function, the convolution, that integral in some other form, other formula. Now we have taken, in this case we have taken another formula. Doesn't matter which form you are taking, we can take any form for the convolution of the probability density function of x and y. So integral from minus infinity to plus infinity fx of w minus y fy of y dy. Here fy of y is equal to 1 by 4 for y values between minus 2 and plus 2, and it will be equal to 0 for all the remaining y values. Integration is with respect to y. So this will be 0 for all the remaining y values, means you consider y values between minus 2 and plus 2 and ignore all the remaining y values. So this integral can also be written as integral from minus 2 to plus 2 fx of w minus y 1 by 4 dy, where that 1 by 4 is kept outside the integral sign. Now to get the answer, we need to calculate this fx of w minus y. W means the sum of x and y. X is between 0 and 3, y is between minus 2 and plus 2. So if we take the sum x plus y, means w, lower limit will be 0 plus minus 2 or minus 2. Upper bound will be 3 plus 2, 5. So the sum w will lie between minus 2 and 5. Now to get this, fx of w minus y dy, see the probability density function of x. It says fx of x will be equal to 1 by 3 for all x values between 0 and 3. Now it is not fx of x, it is fx of w minus y. So if we use that, fx of w minus y will be 1 by 3 provided this w minus y is between 0 and 3. W minus y is between 0 and 3 means w minus 3 should be less than y. W minus y is greater than 0 means y should be less than w. So w minus y is greater than 0, less than 3. So y should be less than w and greater than w minus 3. In this integral with respect to y, when I take fx of w minus y as 1 by 3, this factor as 1 by 3. Remember that y should be greater than w minus 3 values, less than w values. And w value lies between -2 and 5. Since in the integrand we have the probability density function fx, and for fx, x is between 0 to 3, interval of length 3. We'll split this interval for w -2 to 5 into subintervals of length 3. So start with the -2, add 3 to that. -2 plus 3 will be 1. So take the subinterval -2 to 1 as a case 1. Then 1 to 5 is remaining. Again, if you add 3, then it becomes 1 plus 3 means 4. 1 to 4. 4 to 5 remaining. So what we'll do is, first subinterval will take it as -2 to 1. Then I will take it as 1 to 2, interval of length 1. Then 2 to add 3, it becomes 5. 2 to 5. So as the first case will take -2 to 1. As the second case will take it as 1 to 2. As the third case will take it as 2 to 5. So first case, if w is greater than -2 less than 1. W is greater than -2 less than 1. When w is -2, this w minus 3 will be -5. W is 1, w minus 3 will be -2. So for all these w values between -2 and 1, w minus 3 lies between -5 and -2. But here integration with respect to y, and y lies between -2 and +2. So here for w minus 3, which lies between -3 and -2, when w lies between -2 and 1, you ignore all the values, you start from -2 itself, because y starts from -2. So take the lower limit as -2 itself. Upper limit, y should be less than w. Now w is taken as values between -2 and 1, which lies between -2 and +2. So upper limit y, let it be less than that w value, whatever that w value is. So into 1 by 4 into probability density function of the sum z, probability density function of that sum w, fw of w is equal to 1 by 4 into integral from -2 to w 1 by 3. This factor is 1 by 3. 1 by 3 dy, or it is 1 by 12 into integral from -2 to w dy. Integral dy is y, difference at the upper and lower limit w and -2. So 1 by 12 into w minus of -2, w plus 2. As the second case, let w be between 1 and 2. W be between 1 and 2. Then the third case will take it as from 2 to 5. Now y, see the previous slide, y should be greater than w minus 3, less than w. When w lies between 1 and 2, w minus 3. When w is 1, w minus 3 will be -2. When w is 2, w minus 3 will be -1. So -2 to 1. W minus 3 lies between -2 and minus 1, which comes between minus 2 to plus 2. So y should be greater than w minus 3, and that w minus 3 is greater than minus 2 less than minus 1, which comes in the range of y value. So lower limit is w minus 3, upper limit. Y should be less than w. And now that w is between 1 and 2, which lies in the interval of y, so upper limit is that w value. 1 by 4 into integral w minus 3 into w fy of w minus x is 1 by 3. Fx of w minus y is 1 by 3. That integrand dy. So 1 by 4 into 1 by 3 means 1 by 12 integral dy, difference at the upper and lower limit w and w minus 3. So 1 by 12 into w minus 3, which will be 3. 3 by 12 or 1 by 4. Third case, when w is greater than 2, less than 5. Fw of w is equal to 1 by 4 into, now that integral, fx of w minus y dy, where we have seen y should be greater than w minus 3 less than w. When w lies between 2 and 5, that lower bound of y w minus 3. When w is 2, w minus 3 will be minus 1. If w is 5, w minus 3 will be 2. So w minus 3 lies between minus 1 and 2, which lies in the interval of y. So w minus y, which should be greater than w minus 3, and that w minus 3 value lies in the interval of w. So lower limit will be w minus 3 itself. Upper limit, y should be less than or equal to w. Now w is greater than 2, less than 5. So y should be less than or equal to w. So take only 2, upper limit. Y is between minus 2 to plus 2. Y cannot be greater than 2. So upper limit you take it as 2 itself, ignore all the other values. Then the integrand fx of w minus y is 1 by 3 dy. So it will be 1 by 12 integral dy from w minus 3 to 2. So take the difference of integral dy means y, take the difference at the upper and lower limit 2 and w minus 3. 1 by 12 into 2 minus w minus 3 are equal to 5 minus w. 1 by 12 into 5 minus w is the probability density function of the sum w equal to x plus y when w lies between 2 and 5. So w is actually from minus 2 to 5. We have taken it into 3 sub-intervals as 3 different cases. Next question. The random variable x is uniformly distributed between plus or minus 1. Two independent realizations are added. Y will be x1 plus x2. What is the probability density function of y? Again, y is the sum x1 plus x2, where x1 and x2 are two independent random variables which are uniformly distributed between 1, minus 1 and plus 1. Similar to the previous two questions, what is the probability density function of y? Probability density function of x1. x1 is uniformly distributed between minus 1 and plus 1. So probability density function of x1 will be fx1 of x is 1 by 1 minus of minus 1. A is minus 1, b is 1. 1 by b minus a. 1 by 1 minus of minus 1. 1 by 1 plus 1, 2. Half for x between minus 1 and plus 1, 0 otherwise. Similarly, the probability density function of x2, where x2 is uniformly distributed between -1 and +1. fx2 of x is 1 by b minus e, 1 by 1 minus of -1, 1 by 2 for x between -1 and +1, 0 otherwise. So we have the probability density function of x1 and x2 which are uniformly distributed between -1 and +1. We need the probability density function of the sum x1 plus x2, probability density function of y, which is given by convolution of fx1 of x and fx2 of x. So we have fy of y is equal to formula integral from -infinity to +infinity fx1 of x, fx2 of y minus x dx. Here fx1 of x is 1 by 2. So I can write but not for all x values, only for those x values between -1 to +1. So take this fx1 of x as 1 by 2 and at the same time take the integral from -1 to +1. For remaining x values this fx1 of x is 0, so the whole integral will be 0. Ignore it. So fx1 of x is half. Keep it outside the integral sign. So the probability density function of y, fy of y is equal to half into integral from -1 to +1 fx2 of y minus x dx. Now we need to calculate this fx2 of y minus x. First of all, that sum w, which is the sum of x1 and x2. It lies between -1 plus -1 means -2 and 1 plus 1 means 2. So sum of y lies between -2 to +2. And this fx2 of y minus x, look at that fx2 of x, which is 1 by 2 for all that x values between -1 and +1. So replacing x by y minus x, fx2 of y minus x will be equal to half for all y minus x values between -1 and +1, 0 otherwise. So fx2 of y minus x, if it is 0, then we don't have any calculation. So it is equal to 1 by 2 for y minus x between -1 and +1. Integration is with respect to x here. So y minus x should be greater than or equal to 1 means x should be less than or equal to y plus 1. Y minus x is less than or equal to 1 means x should be greater than or equal to y minus 1. So from this we get x value should be greater than or equal to y minus 1, less than or equal to y plus 1. So fx2 of y minus x is equal to 1 by 2 provided that x lies between y minus 1 and y plus 1 and y values lie between -2 and +2. So this will split, because if I take y as the least value -2, then -2 minus 1 will be -3. Greatest value 2, then 2 minus 1 is 1. So lower limit of x will be between -3 and 1. Upper limit will be 1 and 3. But x is between -1 and +1. So we can't take directly this. We need to split that y values. Since the integrand contains fx2 and for x2 the range is interval is -1 to +1, interval of length 2. So split this interval for y from -2 to +2 into sub-intervals each of length 2. So start with the -2, add 2 to that, which will be 0. So in one sub-interval is -2 to 0. Then add 2 to 0, 0 plus 2. 2. So another subinterval is 0 to 2. So we'll split this y values into two subintervals, minus 2, 0, then 0 to 2. So as the first case, we'll take it as minus 2, 0. Then fy of y is equal to. Now x should be greater than or equal to y minus 1, less than or equal to y plus 1. See the previous slide, see the notes. Y should be greater than or equal to y minus 1, less than or equal to y plus 1. Now when y lies between minus 2 to 0, y minus 1, lower bound. When y is minus 2, y minus 1 will be minus 3. When y is 0, y minus 1 will be 0 minus 1 or minus 1. So when y lies between minus 2 and 0, y minus 1 lie between minus 3 and minus 1. So x should be greater than or equal to y minus 1. Ignore that minus 3 to up to minus 1. Take minus 1 because x lies between minus 1 to plus 1. So lower limit, let it be equal to 1 itself. There x was to be less than or equal to y plus 1. And when y lies between minus 2 and 0, y plus 1 lies between minus 2 plus 1 means minus 1. And when y is 0, y plus 1 will be 1. So for y value between minus 2 and 0, y plus 1 value lies between minus 1 to plus 1. And x is the interval from minus 1 to plus 1. So y plus 1 comes in that interval. So upper limit you can take it as y plus 1 itself. And the integrand fx2 of y minus x is a half. So half kept outside the integral sign. Half into half is 1 by 4 integral minus 1 to y plus 1 dx. And integral dx is x. Difference at the upper limit y plus 1 and lower limit minus 1. 1 by 4 into y plus 1 minus of minus 1 plus 1, y plus 2 divided by 4. As the second case, if y lies between 0 to 2, we had x is greater than or equal to minus 1, y minus 1 less than or equal to y plus 1. When y is between 0 to 2, when y is 0, that y minus 1 will be minus 1. When y is 2, y minus 1 will be 1. So y minus 1 lies between minus 1 to plus 1. The interval in which x lies. So y minus 1 comes in the interval of x. So lower limit you can take it as y minus 1 itself. Upper limit. X was to be less than or equal to y plus 1. When y is 0, y plus 1 will be 1. When y is 2, y plus 1 will be 3. Y plus 1 lies between 0 to 1 to 3. But x values, the integration is with respect to x, and that x value is between minus 1 to plus 1. Maximum value is 1. X should be less than or equal to y plus 1, and that y plus 1 is 1 to 3. So ignore all the other values except 1. So upper limit of the integral you can take it as 1. Half into integral y minus 1 to 1. Now the integrand fx2 of y minus x will be half dx. Half into half is 1 by 4. Integral dx is x. Difference at the upper limit 1, lower limit y minus 1. 1 by 4 into, put x as 1 minus, put x as y minus 1. 1 minus of minus 1 is 1 plus 1, 2, 2 minus 1. So 1 by 4 into 2 minus y, or 2 minus y divided by 4. The probability density function of the sum when y lies between 0 and 2, fy of y is 2 minus y by 4.